Hello everybody, problem number 12. The ratio of the areas of two squares is 25 to 7. If the smaller square has a side length of 9 units, what is the side length of the larger square? So, let's think about this situation here. We've got a small square and a large square. The small square has side lengths of 9. We don't know what the side lengths of the larger square are, but we do know that the areas are in a ratio of 25 to 7. And so that 7 needs to correspond with the small square, and the 25 it needs to correspond with the large scale. And now be careful and don't think that you can figure out the area with that 7 and the 9, because think about what we know. We know that this is a square, meaning that that length is also 9, and so we have 9 times 9 is 81. So we know that the square, the small one, has to have an area of 81, and maybe we could use that to figure out the side length of the larger one. But think about another way we could do this. If you think about the fraction that we have, the fraction we have is 25 over 7 or 7 over 25. But we know the area of the smaller square. We want the area of the larger square. So I need to set my fraction up as 25 over 7. Because I need that fraction to be greater than 1, so it causes my area to grow instead of shrinking. And so we want to take 25 over 7, and we want to multiply that by 81 in the area of the smaller square. And let's figure out what we get. We get 289.286 units squared. And that should be the area of the larger square, but we want the side length of the larger square. So think about how we could do that. I keep saying that. I don't know why. The point is, if you know the ratio of the sides, you could figure out the areas, but you can go the other way too. We have the ratio of the areas, which, if you think about the units, are squared, and we want to know about a length, which is just a distance, a single dimension. So we need to take that ratio, 25 over 7, and we need to take the square root of it, because if we have the ratio of areas, 2 dimensions, we take the square root to get the ratio of sides, a single dimension. So this we could go ahead and try and do algebraically. Square root of 25 is 5, so this would become 5 times the square root of 1/7. That's pretty ugly, so let's go ahead and actually figure out an approximate value here. And we get 1.88, wow, 8898. So really, we should change this to 1.890. But is that your answer? No. We know that that is the ratio of the sides. And so we need to multiply that by the length of the side that we do know, which is 9. So we need to take that, and we need to multiply it by 9. So we're going to take that 1.890, and we are going to multiply it by 9. And when you do that, you should get 17.008. And that, my friends, should be the value of x right there. And let's check ourselves and make sure that what we just did actually worked. I got 17, I'm erasing, I got 17.008, which again, this is a square, so that should be the same. So if I square that answer, I should get an area of 289.266, just like I said. But I'm off a little bit. For some reason, when I wrote this number down earlier, I wrote it down incorrectly. That shouldn't be 266. That should be 286. My bad. And that is what we get here as well, 289.286. And what is that saying? Well, that's just verifying that we are indeed correct. We do have that correct scale factor there, and so this lake does indeed have to be 17.008.